All right, so for this problem, we read that Terence notices a pattern developing in the numbers shown. So 3 squared plus 1 is 10, 5 squared plus 1 is 10, whoa, 5 squared plus 1 is 26. Okay, that was a mistake there. 7 squared plus 1 is 50. 9 squared plus 1 is 82. Now, which of the following is a conjecture that Terence could propose based on this pattern? Okay, let's just take a look at what he's got here. 1 more than the square of a prime number is an even number. Well, that would sort of work, except for the fact that 9 isn't a prime number, so that doesn't really apply to this. 1 more than the square of a prime number is a multiple of 5. Well, again, that's not true. Again, for a couple reasons. First of all, because the 9 isn't a prime. And then even that 5 squared plus 1, 5 is a prime. But if you add 1 to it, you are not getting a multiple of 5. 1 more than the square of an odd number is an even number. Okay, that appears to be true in this case here. 1 more than the square of an odd number is a multiple of 5. Well, that's not true. If you look at again, 9 squared, that's an odd number being squared, and if you add 1, it's not a multiple of 5. So the conjecture here is 1 more than the square of an odd number is an even number. So Terence wants to prove the conjecture using deductive reasoning. A first step would be, okay, so based on what he's got here, what we want is to square an odd number. Whoops, I'm not sure why that happened. We want to square something that's squaring an odd number, and then we're going to add 1 to it. So 2n minus 1 represent an odd number, and consider 2n squared plus 1. Ooh, well, that appears to be what we're looking for. Let's just take a look at the rest here. Let p be a prime number and consider, okay, well, we've already known here that if we're starting with the primes, that actually isn't working here in this particular problem here. And let 2n represent an odd number. Well, that doesn't work either, because 2n is going to naturally be an even number. I can't let that be an odd number. So the answer here has got to be A. Now let's take a look at this one. Terence looks at the first 3 rows of the pattern and makes a conjecture that 1 more than the square of a prime number is an even number. Let's take a look at that. So that's this one, and this one. Yeah, so if we square a prime number and add 1, yeah, it looks to be that we're getting even numbers here. The only counterexample that would disprove his conjecture is what? Well, and for a lot of these questions when they're asked like this, there is that one exception in all of the prime numbers, 2. 2 is prime and even. It's the only one. And if I square 2 and add 1 to it, in this particular case, I am going to get 5, which is not even. And so that's the counterexample to that conjecture.